principal designed this, or I don't know. But anyway, so going back to this, got the note sheet online there so you can follow along here. And then we're not doing this notation, what I started off class with. We're going to do this. Stay green, stay consistent. The limit of f of x as x approaches negative infinity. And the answer to this is negative infinity. I always do my X finger, Y finger on this, so you can see the screen here, at least a little bit angled here. And I don't understand how my CAT students don't get this. Input, say it. Output. We're going to be doing a big bunch of that today, especially the end of the notes. Input -3, my output's -3. That's what this notation is. What does Y approach as X approaches this? So as X approaches negative infinity, as I input these X's, this is where the Y's are going. As I always do X finger, Y finger. As this X finger goes to negative infinity, where does the Y finger go? It goes down to negative infinity. And that's why we write that. And then as the X finger goes to positive infinity, where does the Y finger go? And that is positive infinity. I'm struggling on my infinities. All right, critical points, I don't know. For a line, it's not really a big deal. So for other coordinates or other things, we do want to think about some critical points. Then we actually did do this. I'm not going to keep doing this, but just scratch it off and say, not allowed. Not allowed. I will never write that. When we write notes later, it's going to change. Remember the V, very easy. Input, say it. What's the absolute value of 0? Of course that's 0. What's the absolute value of 1? Of course that's 1. But now when we plug in -1, the absolute value of -1 is 1. I do this with the CAT students. We have a section in chapter 1, like in August or maybe September, about what are 9 functions you should know. Parabolas, lines, absolute values, a cubic, which we're going to do today, and then some other ones, exponentials and blah, 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 blah. And I have them input-output. And it drives me nuts that they can't do it and do the input-output and put the coordinates down. Input -1, the output's 1. And then that's how we get this little bouncing V here. Right, so that affects the range. Just pay attention to that. Critical points probably a little bit better. Yeah, you want to know where the, quote, vertex is. And then these 2 points establish the V-ness of this. Of what's happening there. Very simple to do. Input output for this too. I have them have the basic x squared function. 1 squared is 1. 2 squared is 4. -2 squared is +4. -1 squared is 1. So it's very simple to graph those 5 coordinates and make a sketch. If it's not simple for them, they probably shouldn't be in the class. Is actually a true statement. Anyway, scratch that off again. Naughty, naughty, naughty. We do limit notation. And again, the range is a little bit different. Now we can get into our cubic, and this is what we're going to do. We're going to move on from this. It's actually going to be cubic, quartic, quintic. You don't have to worry about those words, but x to the fourths and x to the fifths. We're going to move on to. I don't know what I'm supposed to put in that blank. I forgot, so I'm just going to leave that blank. Draw your own little coordinate plane here. All right, and then we got to make a sketch. Input, say it. Output. So what's 0 cubed, everybody? 3, 2, 1, go. What's 1 cubed, everybody? 3, 2, 1, go. What's 2 cubed, everybody? 3, 2, 1, go. 8. So now we got to get. Now it's getting nuts. I don't think I even gave it enough space. And then what's -1 cubed? 3, 2, 1, go. No, it's -1. A negative times a negative. So we got a little difference here between a quadratic and a cubic. And then what's -2 cubed? 3, 2, 1, go. It's actually -8. 3, 4, 5, 6, 7, 8. And then this is what we have. All right, and then that's your first cubic function. We're going to move on from this and quartic and all, like I told you. So we got to get some terms taken care of today. And hopefully you get domain and range. I can cube any number and get an output value. So there is no restrictions on what I can plug in. The only restriction, the first restriction we had is when we had a square root graph. That's another one that I have my CAT students doing that basic functions thing. You can't take the square root of a negative in the real world, so the domain's affected. All right, hopefully you remember that. And then for range, I always say this. This is range. What y values are covered? All of these y values are covered. Every single one of them. The y values exist in this graph. All right, so it is all real numbers. The way to look at range is to look at the graph and look at the y values that exist just by looking at the y-axis, and does the graph exist left or right of that? It should be pretty easy. All right, and then we'll do the end behavior the right way. Limit, well, I won't say the right way, the like calculus kind of way, the way that we were supposed to be doing in all classes, but I see that we don't in Math 3 regular. I see their work in tutoring. All right, so X finger, Y finger again. Last time, when I input -2, I get -8. When I input -3, I get -27. This is going nuts. As I plug in more negatives, the Y's start taking off negatively. So it goes to negative infinity. And then the limit of f of x as x approaches positive infinity. I don't think I have to walk to the graph. It's infinity. Some critical points would probably be that 0, 0 point. That's actually called a point, I think, of inflection. It's just like a little flattening out point, but it never changes direction. This is like increasing forever, right? So it is, that's it. All right, and then, one cubed is 1, and then the big deal, -1 cubed is -1. Now, just those 3 points alone doesn't really establish a cubic. Those could be linear if you plotted those 3 points. You got to know the cubic, go to the next set of points, then you start seeing the curvature taken off. So I kind of argue about the critical points there. It's not really too critical. It's just, got to know that flattening out stuff. All right, absolute compared to relative extrema. Absolute extrema deal with the entire domain of the function, where relative extrema deal with the specific interval of a function. Kind of true, but really we need to clean this up a little bit. Boom. We've actually had this before. You might want to make a little quick sketch of this right underneath this. For that absolute value function, that's funny, absolute value, absolute minimum. Not related there, those two words, but that point right there is the absolute smallest y value for this graph. So therefore, it's actually called an absolute minimum. Because there absolutely, positively, without a doubt, there is not a lower y value. So really hammer down the word absolute on that. For this upside down parabola, and actually a right side up one would have an absolute minimum. But I went upside down on this parabola. That is absolutely the highest y value of the whole graph. That's what this definition, and look at the whole input values, the whole domains. That is absolutely the highest y value. There is no one that's higher. This is what's going to happen with x to the thirds. You've not seen this yet. But once I started adding more to an x to the third equation, like y equals x to the third plus 2x squared minus x plus 4, then you're going to start getting a roller coaster. The end behaviors are the same, but that little flattening out in the middle starts turning into a little roller coaster. Think about it that way. I'm going to Cedar Point again this summer. Anyone ever been to Cedar Point? Nobody in this class has been to Cedar Point? You just don't like raising your hand. I find that remarkable. It's one of the best roller coaster places. But anyway, when you get this happening, this is the idea of this as you're writing this down. Make sure I didn't hit the wrong thing there. Locally speaking, just in this little area, this spot right here, and ignoring everything else, this is the highest y value. But it is not the absolute highest y value of the overall graph. So that's why this is called a local or relative maximum. I don't know why I have relatively. That should just say relative. All right, so I'll erase that. Relatively speaking, all right, but I'll go ahead and erase that. But that's why I wrote it on accident. Relatively speaking, to this little spot right here, that's the maximum, right? So local is a nice, better word. And then this is the relative or local minimum because it's not the absolute minimum. The minimum actually goes off to negative infinity, so that's not the lowest y coordinate. Should be no problem with that terminology. It makes sense. So on and so on and so forth. Okay. Now, what are we doing on this? Oh, okay, sorry. I zoomed in off of that. So I kind of drew a line there to get that stuff in there. Now, what is the leading coefficient? As a matter of fact, I can come up with the equation of this line. What is the slope of this line? Look at it. Take a guess. Nice whole number. And now I'm going to ask you in 3, 2, 1, go. Ooh. Oh, it is 2. Okay. And it is positive, right? I thought it was 3. Did I write 3 last hour? I wonder if I did. I think I wrote 3. All right, because I thought it hit up here. So it's probably between 2 and 3. So somewhere around 2.5 to 3. Let's just stick with 2, which most people said. All right, so what that means is the leading coefficient then is positive. And how I can think about this in the future is how it ends, the end behavior. All right? How this ends is what the leading coefficient is. And that's going to actually be the truth with the next to the third. So what is the slope of the second one? 3, 2, 1, go. -1/2. And I do have a y-intercept of 0, so it is just -1/2 x. All right, so this is a negative slope. All right. And I guess that's all I have to say about that. Okay, so what's this next one? Letter C, positive or negative leading coefficient. 3, 2, 1, go. Negative. Okay, and actually the graph of this would probably be y equals -1 times the absolute value of x. Input, output, I plug in 1. The absolute value of 1 is 1, but then when I multiply by -1, I get -1. All right, so the leading coefficient of this is negative. Last one, letter D, positive or negative. 3, 2, 1, go. This is y equals a positive number times x squared plus a bunch of other stuff lower than x squared possibly. All right, so this is a positive. So end behavior, how this ends is really what dictates what my leading coefficient is. Same thing with an x cubed. So we'll have to know that. And then here we go. We have a lie here too, cubic functions. Letter A, how does it end? What's the leading coefficient, positive or negative? 3, 2, 1, go. Positive. Letter B, positive or negative? 3, 2, 1, go. Negative. Letter C, 3, 2, 1, go. Ooh, letter C is down here. This is a positive leading coefficient. Positive leading coefficient. Negative. Here's the lie. This is not a cubic. This point of inflection actually counts for 3 degrees. So if I just had this right here, didn't see anything else, this would be a negative x cubed. All right, but then I have more terms. This is actually an x to the 5th minimum. So you might want to make a note to self. This is minimum an x to the 5th, so it's really not a cubic. But what's the leading coefficient? 3, 2, 1, go. Negative. You'd have a negative x to the 5th as the high top dog coefficient. Okay, all right, going to the next page. You should be familiar with these. Fumble. Oh, man. Nope. Okay. So we have this picture now, a classic x cubed with some more action going on in there. We could actually make a guess of the equation after we do the end of the notes, but we just won't have time. That'll come later. Okay, so the sign of the leading coefficient, we just went over all of that. It would have to be negative because of the way this ends. The way the limit of the limit notation would be. For an x cubed and actually any polynomial function, you have no restrictions on what you can plug in for x. The only thing I can think of where we had restrictions was that square root I was telling you about that we did earlier in the year. Can't think of any others. We haven't graphed rational functions. Ooh, that'll be next year, I think, right off the bat. And then range. All of these y's are covered. All of these y's. You know what I actually said with my class 2? I used the term one-to-one. This goes all the way back to maybe August or September. Is this function, first of all, it's a function, right? Vertical line test. Remember the vertical line test? It hits every part of the graph only once. Is it one-to-one? Yes or no? 3, 2, 1, go. It's actually no, because these y's repeat in the middle right there. That's what one-to-one means. So right here, horizontal line test, put that down. This is not a one-to-one function. I did teach you that back when we talked about functions in general, when we were doing inputs, outputs, and talking about that. Inputs domain, outputs range, function. We can't have any repeating x's, but if we have repeating y's, it's just said not to be one-to-one. So just a little added thing. But I was in the middle of doing range, and I proved that it's all real numbers. All the y's are covered. All right, now, notationally speaking, I'm going to erase some of my things that I have here. Relative maximum is right here. This is what you need to understand. This is talking about the y coordinate when they say, what is the relative maximum? So the relative maximum, and it is relative to this area, this takes off forever, so it's not the absolute maximum. Maybe to make a note to self why we're calling it relative. But it is 6 and then located at, that's how you mention the x coordinate. Sorry, x equals 0. So the local relative maximum is 6 at x equals 0. Located at, sorry, I forgot to put the word at in there. Sometimes they just say is 6 at x equals 0. You don't have to have the word located necessarily. And then same old with this one. This is 1, 2, 3, -4. So this is -1 at x equals -4. We'll write that in that shorter way and not have to write the word located. Okay? Is -1. Same thing with intervals of increase and decrease. This comes into the people that are, listen and get these little details. There's a lot of details that you have to keep track of. People that get A's take care of those details perfectly. And this is another one. When you take to note, how do I get all the right answers? Okay, intervals of increase. The word increase is already describing the y's. And then actually we read graphs left to right. So we've got to make sure we understand that as well. So where is this increasing? I'm going to use my highlighter, and I suggest you do the same. Another fumble. This is where the y's increase from here to here. So I want you to understand this. This is redundant if you put the y values in this blank. It's just like, what is the relative maximum? It is 6 created by x equals 0, input, output. All right, so I've already taken care of the output. What inputs make these y's increase? So what I'm saying is you need to name the x's as that interval. And the x's are from -4 to 0. So I input -4 to 0 in order. I input these x's to create these increasing y's. And then you know why it's parentheses? Well, let me finish with decrease and then I'll tell you. Obviously, this is decreasing, and obviously, this is decreasing. So interval of decrease as I read left to right. And then what are the x's that make this happen? All the way forever over here, going in this order, all the way up to -4. So it is -infinity to -4 And then I don't think I really need a union sign in between these. It's just two different intervals. And then this is 0 to infinity. And again, decrease describes the y. These are the inputs, the x's that make it happen. You writing that, and then the point of taking notes is when you write this stuff, you're actually writing it in your brain. You're activating your brain in a different way, and then you make a point of this. This is again the bums that don't take notes. I got no sympathy for you, none. Don't complain when you don't take notes. I shouldn't have to even talk about that anymore in this class, right? But why parentheses? Someone might think, why not do I put brackets on this? And the idea, remember tangent lines on a circle? It's a line that just skips off the circle at one point, right? Do you know what the slope of the tangent line is right at -4? What's that slope? What's the slope of a horizontal line? Because that's the point of tangency right there. 0. Because at -4, there's a change. It's not increasing or decreasing at that exact point. The slope of the tangent line at this curve is negative. That proves the decreasing. The slope of the tangent line somewhere right here goes like this. That's increasing. That proves the positive slopeness of the graph. That's calculus. They do math to get those get those points and really talk about that a lot. Okay, x-intercepts are easy. Make them coordinates though. I'll go left to right. Oh, nope. 2, 0. I must put a negative there. 1, 2, -3, 0. And -5, 0. Then we already found the y-intercept. That was that maximum, right? Local maximum. Yeah, relative. Same thing. And then I think you can get this pretty easily. I want to get going faster here. So we already talked about this. X finger, Y finger. With that negative leading coefficient, I guess I should ask that, but definitely a negative leading coefficient. As x goes to infinity, y goes to negative infinity. That's why I did that in the second one. All right. All right. So wait there for a second. I know we wrote a lot of stuff there. Your homework should be way faster than these notes, but I feel like there's a lot of stuff I got to remind you of. And hopefully you're sitting there letting it all sink in. A lot of repeated information or review information. Because of time, I'm not going to be able to do this whole chart. I guess we'll call this like 1, 2, 3, 4, 5, 6. And then we need to match them with the pictures down there. So I did this a little bit better. I'll do 1, and then I'll talk about 3 and 4, how we can disseminate those two and not do the rest. And then notice the relative max is 4 at x equals 1. You'll notice how that's stated there. We could find that picture. And I guess I could go through all these and then figure out which one's which. I guess I could do that on the video. But it does look like that this is number 1 right here, because those are those x-intercepts, right? So that's pretty easy. Relative maximum of 4 at x equals 1. I just need to find one that has 1, 4 as a relative maximum. And then I guess I should have put A, B, C, D, but it is. It actually is graph number 3. It does have this here. All right, so I guess I kind of have to do this. 1, 4, that is a relative maximum. So this is number 2 up there that matches with this. You do a process of elimination here. Good thing this is in order, because number 3 says intervals of decrease, negative infinity to infinity. That means there's no change in direction. So it's either got to be graph 4 or graph 5. And I guess that's what I should have done. I should have put the numbers up there. But this is the third equation up there, matches with the 5th graph. Because that sucker is decreasing forever. This is just a point of inflection. So that means the next one has to be graph number 4. There is no relative minimum. This graph has no maximums or minimums. That's the parent x cubed, which doesn't have the roller coaster. So this is number 4's equation. So I guess I should have, I didn't notice those numbers in the right. So any 4's equation graphs with 4's graph. Right, and then so on and so on and so forth. You get how it works. You could probably fill in the other ones. And then same old, same old. What's the y-intercept? Does make me sad when students can't look at a picture and tell me the y-intercept as a coordinate. Actually, that's a lie, isn't it? What does it really look like for a y-intercept? Looks like -5.5. So I lied. Squeeze that 0.5 in there. And then relative maximum, look at how it's worded there. So it's going to be worded the same here. Relative max is, let's just say 5. Let's say it's right on 5 at x equals. Go ahead and write that down. Sorry, wrong. It's at x equals 5. So 5 comma 2 is 2 at x equals 5. Sorry, I switched that around. Switcheroo. And then is -7 at -2. And then intervals of increase, we got it from -7 to 5. Remember the x's. And then a couple intervals of decrease, -infinity to -7. And then 5 to infinity. All right, and then I'm not doing the rest. We got other things to do here. Okay, again, filling out these things. You can see your homework sheet. It's got those charts on there. Don't have time to do this, but you could on your own if you cared. You go to desmos.com, type in transformation of cubic functions, and you can play around with this and see what this does to the cubic function. All right, I'm just going to note them here real quick that we should remember this from back in August, September, probably September, October, November was when we hit this a lot with our basics functions here. Remember, this is a stretch shrink of the graph. Fumble. Shrink. I forgot to say that in the other hour. They'll handle it. We're going to do input. Say it. You'll see the stretches and shrinks, but not really. It's kind of, cubics kind of take off pretty quick, and it's kind of hard to see this. Do you remember this? Opposite, same. Remember that? So when it says x minus 3, 3 is the h value. So x minus 3 means right 3. When this says x plus 3, that means h technically is a negative. Not technically, it is, because of the way this works. So opposite, same as far as how this shifts. But input output's going to take care of this. And then k is same. When k is positive, that's up. When k is negative, that is down. You don't really need Desmos because it really takes away your right to input, say it, output. Okay, so we're going to go ahead and do this. And as a matter of fact, on my table, on my next quiz, probably have a quiz and then a test in this unit. This unit's going to be pretty long. I'm going to have my table blank because you should know the very first x coordinate you should plug in from my class. What is the first x coordinate you should plug in? -3. It's the 0 of that, which is the most important coordinate. Remember in the very beginning of the notes, what are the key coordinates? You want to know where that point of inflection is. And that's all we're going to have on this is a point of inflection. It's not going to be a roller coaster. So you want to know where the most important coordinate is, and it's at -3 comma. So -3 plus 3, this was bad. This is really bad with my CAT students, the ability to just evaluate numbers. -3 plus 3 is 0, 0 cubed is 0, 0 minus 4 is -4. The ability to do that without a calculator. All right, 1, 2, 3, 4. You should really test yourself mathematically to not pick up the calculator throughout any math class when you're doing homework, and then maybe type after just to check yourself. But that shouldn't be a problem. We have a quick question. -3, I did put -4. Oh, I put 4 on the graph. Right. Thanks for keeping me honest there. I would have found out -3 comma 1, 2, 3, 4. And this is a good point. when I do the next coordinates, I knew I would have made a mistake because I know this is supposed to go like this. So knowing what the shape's supposed to look like, I would have been able to catch myself. So, but good, thanks for telling me there. Now calculations. -4 plus 3 is -1. -1 cubed is -1. -1 minus 4 is -5. All right, knowing how to take a negative minus another negative increases the amount of negatives. All right, so -4 comma -5 is this point. And then once I would have got that point, I would have known that other one was way off. You know what I'm saying? So I knew I would have caught my mistake. -2 plus 3 is 1. 1 cubed is 1. Now 1 minus 4. 1 minus 4 is -3. And now that's where we get that little flattening. This takes off quick, kind of. -5 plus 3 is -2. -2 cubed is -8. Fumble again. -8 minus 4 is -12. Now that's off my scale, so I'll just kind of go like this. All right, so man, we're really taking off there. And then -1 plus 3 is 2. 2 cubed is 8. 8 minus 4 is 4. That's not too bad. -1 comma 4. -1 comma 1, 2, 3, 4. And then 0 is really bad. And it just proves the point how quick this takes off. 0 plus 3 is 3. 3 cubed is 27. 3 times 3 is 9. 3 times 9 is 27. 27 minus 4 is 23. And that's off the scale. So really, to do this justice, this graph doesn't even hit the y-axis yet there. It gets really steep, right? You know, it hits it way up. That's only 10. I have more than double to go on that in order to get up there. All right, domain and range for cubics is always all real numbers. There is no restrictions. What's great about this is I don't have to worry about relative minimums or maximums because there aren't any. That's just a flattening out point. Interval of increase, it does it forever. That point of inflection, that flattening out point, never stops increasing. Flattens out a little bit. Oh my gosh, that's a huge fumble. All right, so there's no decrease. We literally, was that your phone too? Oh, your highlighter, okay. It's a big highlighter. All right, y-intercept is 0, comma 23. I'm so hungry. Oh, we have Compass today, don't we? No, you can't come. If you didn't sign up yourself, you're getting penalized. Limit, you have not signed up yourself once. I'm not enabling you anymore. What a mean teacher. It's almost May. They're supposed to do this themselves. How else can we teach them instead of making them do it themselves? All right, negative infinity. All right, so it's negative infinity as an output value. Limit of f of x as x approaches positive infinity. All right? You can see that with your XY fingers pretty easy. I think I skipped the next one. I probably should have done this one first, but I'm just going to move on. I want to go to the next page. We're running short on time, and I don't want to go the whole time, although it's probably going to happen. Again, I would probably have none of those written for. I'd have it all blanked out. Because now we should understand that this is actually called intercept form. And the reason is, what happens when I plug in -4 for x? -4 plus 4 is 0. What's 0 times who cares times who cares times who cares? What's the answer? 0. So that's why we know when we plug in -4, we get a 0, which is an x-intercept. 1, 2, 3, 4. And then when we plug in 3, we get a 0 for the same reason. I don't have to over-teach here in this high-level math class. Okay, 3, comma 0. And then what's the other one? 1, comma 0. Almost missed that one. And then the other points are just to get some shape out of this graph. And I actually got some problems with these 4 things. Relative min-max, interval of increase and decrease. But we'll wait. Let's plug in some numbers. This gets kind of crazy, so I'm going to keep track of my numbers up here. This is when I plug in -5. I guess I could write this in function notation. Plugging in -5 is half -5 plus 4, which is -1. -5 minus 3 is -8. Knowing how to calculate, the fact that you don't think about the numbers is why you can't calculate that. You go to your calculator and like a robot press buttons. That's bad. We should know -5 minus 3 more. I owe 5 here and I owe 3 over there. I owe 8. All right, it's very simple. And the -5 minus 1 is -6. This is a huge number. So -8 times -6 is 48, but then times -1 is -48. Half of that's -24. How ridiculous. At -5, this sucker takes off. I can't even hit that point. So this is a very, very connecting these 2 points steep part of the graph. All right? And that's what that means to me, because -5, -24, this isn't even correct where it's at. It's even lower than that. Okay, make sense? Okay, so then -2 is not so bad. F of -2 we'll put over here. Guess I'll be a real true mathematician here and write this. -2 plus 4 is 2. -2 minus 3 is -5. Right, we're doing -2. And then -2 minus 1 is -3. So even this one's pretty large, pretty high. Half of 2 is 1, and then -3 times -5 is 15. So at -2, we get 15, which is off the scale. That's not even that high. Then I will plug in 0. I guess I could put this here, f of 0 equals half. And then what do we get for the 3 numbers? Very easy. 4, -3, -1. That's what 0 plus, 0 minus, and 0 minus becomes. That's -12. Wrong. That's 12. Half of 12 is 6. Now we at least get the y-intercept. 2, 3, 4, 5, 6. Now when I connect these, I got this. And then this so far. Now here's my point on this. We're not answering these. We're going to be really specific on this. There is no telling that is the maximum. It could be fractional. It could be like at -2.5 or -1.5. There's nothing to say that is absolutely the relative maximum. So we don't have the ability to answer those questions technically, and I'm not going to. I'm not going to put a false thing down there. That's where calculus comes in. There's your graphing calculator. If you type this in there, there's a thing that you can find maximums and minimums, and I think we'll get into that. But I'm not putting an incorrect answer up there. We're not going to guess. F of 2. All right, so half. 2 plus 4 is 6. 2 minus 3 is -1. Had to think about that for a second. And then 2 minus 1 is 1. Okay, that one's nice. Half of 6 is 3, then multiplied by a negative. So 2, 1, 2, 3. Now, because this is exactly in between these two, this may very well be the relative minimum, but still, you got to be careful on that. I don't want to put a false thing down. And then f of 4, I'm not writing it. 4 plus 4 is 8. 4 minus 3 is 1. 4 minus 1 is 3. So 3 times 8 is what happened, I believe, right? 4 minus 1 is 3 is 1. 4 by 3 times 8, 24. Half of that is 12. Okay, so I don't have to always write them out. I don't expect you maybe to write them out, but whatever you got to do. And that's just a little bit off the screen. So there you go. Domain range. Last one of the day. I'm not guessing on these. We'll get these later with technology. In calculus, this is when you do derivatives, right? And derivatives are slope of tangent lines. So basically, when you really find this relative minimum, it's where the slope of the tangent line equals 0. And that's what a derivative is, if you've ever heard of that term before. You don't have to know that now. -4, 0. 3, 0, and 1, 0. Then the y-intercept is 0, 6 found by plugging in 0 for x. And then the limits, and then we'll end the video. As x approaches negative infinity, y finger goes to negative infinity as well. Limit of f of x as x goes to infinity, infinity. Okay, so there it all is. Only going to do 2 of those. I probably could have condensed this to one less page and just did one of each of those, knowing the time. All right, a lot of review in there, so there shouldn't be overwhelmness of this. Input, output's not a big deal. The expectation of what your picture looks like. Maybe on these graphs where we're doing guesses on these points, hold off on this section. It really isn't appropriate to be guessing on those if you truly want to be correct.